Alright guys, I'm going to give you some of the basic information to help you with the problems, screw problems when you're doing AMA, IMA, and efficiency. And again, um, just like always, your AMA and IMA and efficiency formulas are all the same. Okay? In other words, when you're calculating the IMA, like I'm highlighting right here now, IMA equals your distance of your effort divided by your distance of resistance. When you're calculating the AMA, again, it's your distance of your effort divided by your distance of resistance. When you're calculating the efficiency, I'm highlighting again on the bottom now, it's AMA divided by IMA, and we're going to multiply that by 100 to give us a percentage. So the only thing that's different on the screw problems is that you have to find out where do you get your numbers from. Okay, in order to calculate the IMA for the screw, okay, your distance of your effort is the circumference, okay, the circumference of a circle that's made when you turn a wrench, okay, one full turn. Okay, like you see down here on the bottom of your picture right now, here's a wrench that's attached to a screw, and if you turn it one full turn, okay, it doesn't look like a great circle, but it actually makes the shape of a circle. Okay, so we're going to want to know what the circumference, or what is the distance of that circle that's made, because that's our effort distance. The distance of our resistance, or the distance of the load, is what we call the pitch, okay, of the screw. Well, the pitch of the screw is the distance between two threads. So you can see on the screw up on the right hand side here, or any of the screws that you're looking at a picture of a screw, okay, two threads together. It's going to hard to do with my stylus, but that's the distance right there. I just made the up on the upper right hand corner, if you didn't see me. Okay, this screw right here, I just made these two marks. Oops, now I'm messing it up. But the distance between two of those threads is what we call the pitch. Okay, and I've gone over before, and you've seen it in your notes. Here again is a picture of the pitch. Okay, here in the upper right hand corner. How do we know what that distance is? Well, remember, we have to use, I'm over here on the thread information now with the highlighter. Okay, and I'm highlighting the main information. The most important information that we need for calculating the IMA is this number right in the middle. Okay, for this particular screw, and every screw has its own thread information. Talks about the diameter. Okay, again, I'm on the right hand side, the diameter from here to here, okay, of the screw. And it talks about the threads per inch. Sometimes it's just labeled as TPI. TPI stands for threads per inch. And then this third part here is just information about the coarseness or fineness of the threads. Okay, to get the pitch, we take the threads per inch. We take 1 divided by whatever number that is. Okay, so in this case here, it's 1 divided by 13. Okay, because we have 13, and I'm just making a big circle on this number where I highlighted the threads information. It's 13. Okay, this screw here, this next one, okay, where I'm up on the right hand corner now, we have, it's 1/4 inches in diameter, and it has 20 threads per inch. So if I want to know the pitch for that, I divide 1 by 20. Okay, so let's take a look right here now in the middle of the page where we're going to actually apply this information. Okay, so the circumference of the circle that is made, you have to look at, you always have to find, in order to know the circumference of the circle, you always have to find how long is the wrench. Okay, now I'm making some marks here. How long is that wrench? Because if you look at the bottom circle here, or the bottom picture, you notice again, here's the length of the wrench. That length of the wrench is the radius of the circle. The radius of the circle is from the middle of the circle to the outside edge of the circle. So however long that wrench is, that's the number that we need as the radius to calculate the circumference of the circle. In this problem here, okay, we're told that the wrench is 8 inches long. Okay, and you can see it right here. It's 8 inches long. Sometimes it just tells you in the problem itself that it's 8 inches long. So the circumference formula is 2 times pi times the radius. Okay, if you knew the diameter, it would just be pi times the diameter. But in this case, you've got the wrench length is the radius, 2 times pi times 8. Okay, and you're going to divide that by 1 divided by 20, okay, which is equal to the pitch. Okay, and that's what we were talking about up here. The pitch is equal to 1 divided by the threads per inch. Okay, and in this one here, we were told that the threads per inch is 20, so we go 1 divided by 20. And when we do that math, you get 1005.31, this number right here. Okay, that's the number that we get for our IMA. For AMA, this is a lot easier, okay, because all you're doing again for AMA is you are dividing your force of your resistance divided by your force of your effort. These numbers in word problems will be given to you very straightforward. Okay, so for this one here, your force of your effort is going to be right here. Okay, it's how much effort are you giving when you're turning this wrench. Okay, and it's 35 pounds. Your force of resistance is going to be the load that's put on the screw, okay, as you're turning it. Okay, so 1,200 pounds. AMA is your force of resistance, 1,200 pounds, divided by your force of your effort, 35 pounds. And that gives you an answer of 34.29. Those are the numbers that we're going to plug into our efficiency formula right here on the bottom. Efficiency formula, AMA divided by IMA. 34.29 divided by 1005.3 gives you this number, 0.0341. Okay, and times 100 gives you 3.4%. So that's that's how you calculate that. Okay, so hopefully you guys are not having problems with that. If you have questions, please don't be afraid to ask. Yeah, I don't know really what else to tell you. The question here, why is efficiency so low? It's because your input work is much greater than your output work. Okay, so you guys can do this.